Okay, today we're going to focus on light energy, and we're going to describe some properties about light energy and how light behaves. So this is Learning Target 20. You should be able to develop and design scientific investigation regarding absorption, reflection, and diffraction of light. Okay, light is just a narrow beam of light energy that travels in a straight line. It can travel through space. It does not need a medium, meaning something for it to travel through, and it travels faster than sound. Okay, so light can do a couple things. Reflection is when light waves strike an object. I'm sorry, I didn't see that. An object or surface and bounces off. So we're going to watch a little interaction to show how reflection works. So we see objects because light rays enter our eyes after bouncing off rough surface. What if the material is very smooth surface? So we're going to click to find out. Smooth surface, like a mirror. When light rays hit a very smooth surface, the light is reflected at equal angles. This means we can predict or work out what will happen. So it says make your own prediction now. Drag one of the light rays on the right to the position you think it's going to do. So if we think it's going to come back at the same angle, why can't I move that? There we go. I'm going to try this one. Yay! We're going to check it. See how good Miss Stevens is at this? Now click the switch, so we're going to do the switch. Aha! I've got it right. So these two angles are the same. This follows the law of reflection. This is called the angle of incidence, angle of reflection. I think they'll go over that. Okay, mirrors allow us to see around corners. Click the torch switch. Let's do that. There we go. We would not be able to see fleck, I guess that's the name of that little funny object. Without the mirror, light cannot bend around a corner, but it can be reflected. If you look straight at the mirror, light waves are reflected back at you. That's why you see yourself. So Fleck's obviously going to do that. So he looks right back. He looks at the mirror, reflects back at the same angle. There he goes. Okay, that's what I think is going to happen. I'm going to check. Yeah. Okay, so click on the correct word for each sentence. Mirrors have smooth surfaces. Light is reflected at equal angles. Image from mirrors are back to front. That's right. We're all rock stars. Okay. So that's reflection. So if you take a look at this, the angle of incidence is called the incoming ray. Okay, so the incoming ray is the incident ray. Okay, is going to be equal to the reflected ray. So that's the law of reflection. Okay, and I believe there was one more. I need to stop moving these. Sorry. Okay, one more thing I want to show you with drawing reflected rays. When you draw, here's the light source. These are all the incoming rays, the incident rays. These are all the reflected rays that bounce out. Now, if you want to find out where the image is seen on the other side of the mirror, you draw the reflected rays through the mirror. Where they all meet is where the image location is. So I'm going to show you that again. So these are the incident rays coming in and hitting the mirror. The ones that come back out, are the reflected rays. If you take those reflective rays and extend them past the mirror, you always have to use a ruler when you do this, where they intersect will be the location of the image. It should be the same distance away. So if this is 2 centimeters on this side, this should be also 2 centimeters. Okay, well, what happens if the image is not, or the surface is not smooth. If the surface is not smooth, then light rays will not reflect equally. So this is called diffusion. Waves strike uneven surfaces, reflective rays go in many directions. This is why you can't see an image of yourself on surfaces that are rough. Okay, you can only see a reflective image of yourself on a smooth surface like a mirror. So this is what happens when you have diffusion. These are your incoming rays in blue. Notice the reflective rays in green. They're not at equal angles. They go all different ways. And this is your rough surface. So that's diffusion. So when you have a smooth surface, light rays will reflect at equal angles. If you have a rough surface, then light rays will diffuse and reflect at uneven directions and angles. Another way that light rays can behave is refraction. Refraction is the bending of waves as it moves from one medium to another. A medium is what energy travels through, like space, water, and air. And energy will travel at different speeds when it travels through space, water, and air. So if you take a look at this light ray, as it's traveling through air, it travels at a different speed. When it hits water, the light ray bends because it travels slower through water. So it's going to go at a different direction. Now, when we look, like if we're looking at a fish tank and we look at our fish in the fish tank, we are only looking at the light rays through air. So we think the fish are in this position. When in actuality, they're here. Because we are not in the water, we can't see the light rays bend. But when light rays bend, that is called refraction as they travel through different mediums. You've seen this before when you've used a prism. A prism is a piece of glass. If you take a light ray and it travels through air and then it hits the prism and it switches and travels from air, that medium, to glass, it will actually refract and you will see all the different colors of a light ray. So that's a way light ray can behave when it travels through different mediums. The last one is diffraction. This is also a bending of waves, but it's bending of waves around a barrier. So this is when light rays hit a barrier. Sound waves diffract more than light rays because they have smaller wavelengths. So that's why if you can hear people, if there's a crack in the door, you can hear their voices on the other side because sound waves have a smaller wavelength, so they can actually bend around the door a lot easier than light can. Okay, waves will diffract more when wavelength is similar to the size of the barrier opening. So let's look at some examples. Okay, so a barrier could be like a door, a wall, anything that's going to block the light and stop it from going through. So here's your light source. There's light waves that get hit by the barrier. They don't go through. The other light waves go around it. That's called diffraction. Here's another example of that. You see an example of diffraction every day when the sun travels through the clouds. It diffracts because the light rays have to bend around the clouds, and this right here is an example of diffraction. Okay, the last thing we're going to talk about in relationship to light waves is we're going to talk about how light waves can be absorbed by matter, and that's called absorption. So there's three different ways that light waves can be absorbed: transparent, translucent, and opaque. So matter is either classified as transparent, translucent, or opaque, and that has to do with how it lets light waves reflect. So transparent objects allow one or more frequencies of light to be transmitted. For example, okay, if you have this barrier right here, this matter, and waves hit this piece of matter, it tells you that the pigment in this matter is capable of absorbing Roy G. Biv. So it's going to be able to absorb all of those light frequencies, meaning none of these frequencies will be reflected back to you. So this matter is what we would call opaque. It's not going to reflect any light rays. If you look at example B, it says this pigment is capable of absorbing R. So if light is shining red, green, and blue light at this matter, it'll absorb the red light and reflect back green and blue. So you'll be able to see green and blue. This would be a transparent object. So transparent matter is going to let all or most frequencies of light go through. So if you look at these objects, they're letting light, all frequencies of light, travel through so that you can see them, and that's a transparent object or matter. Translucent absorbs some frequencies of visible light, but not all. So you can sort of see through these and see some of the light that gets transferred through. These are examples of translucent objects. Opaque absorbs all frequencies of light. So opaque objects you will not be able to see through. So these are examples of some opaque objects that you cannot see through these objects because they're absorbing all frequencies of light. Okay, so hopefully after today you are going to be able to tell the difference between reflection, refraction, and diffraction and what happens to light in those instances. And you'll also be able to describe matter based on how it absorbs light through transparent, translucent, or opaque objects.